We're solving problem 25 from the AMC 12B from 2022. Four regular hexagons surround a square with side length 1, each one sharing an edge with the square as shown in the figure below. The area of the resulting 12-sided outer non-convex polygon can be written as m squared n plus p, where m, n, and p are integers and n is not divisible by the square of any prime. What is n plus p? So we have this shape here, and we know that the smaller square has side length 1. Yeah, and in the problem described it, there's four hexagons, each rotated 90 degrees on some face of the square. So if there's this hexagon here with these 6 points, and since the problem states they are regular hexagons, we know that all of these side lengths are just going to be 1. So we want to dictate a few variables here. Well, first of all, let's just let this length from the edge of the square to this side length of one of the hexagons be x. And we know that x is equal for all points here, as the area of all the hexagons are the same. Now, what we can do here is we can basically draw some lines to make this figure easier to compute. So we have the area of the square, and then this sort of very low poly donut-ish shapey thingy. So if we just draw lines going completely vertical here, like there, this is going to be pretty simple of an area to find. Okay, as this height is simply the height of this big rectangle minus 1, which is the height of the square, and then we know that this length is 1, and there's 4 of them in each side. The real problem is these triangles. Well, we know that that length dictates x, so we want to set some variables, but first let's just figure something out here. So we know that, say, this whole hexagon, it has, well, if this length is 1, we know that a hexagon is divided into 6 equilateral triangles. So by using that, we know that the height is 3. Let's see here. If we just draw a hexagon like this, we note that this total length is going to be 3. Let's call this one A, B, and C points, respectively. We know that since the sum of the angles in a hexagon is 720, each of these is going to be lengths of 60. So when you divide that by 2 with the vertical bisector, there's going to be 30, angle 30, and angle 30. So this is a 30, 60, 90 triangle, because this is clearly a right angle. So now, well, what we can do here is we know this height now. That is simply, well, we find that actually not the whole height is square root 3, but we can sort of draw out the equilateral triangle as well. Not too good. Like that. So we can find that this length BC is equal to the square root of 3. So we know that the whole length of AC is equal to 2 times the square root of 3. So now we know that this height here, that height is going to be 2 times the square root of 3 minus 1. That's that height. So we have that. We have that area. Now we want to find, well, this strange triangle area. And, well, this is really divided into 4 parts with a triangle, correct? So we know that if you divide it into it, this height of a triangle, if you draw it like this is going to be x root 6 over 2, and the base is going to be x root 2 over 2 when you solve the whole thing. So basically, this whole area is when you add up these 4 of these rectangles and 8 of these triangles. So the main variable we have to really solve for is x. We can have a representative of the height and set it equal to the total height, or in this case, one of the heights, which is the square root of 3. So we know that this height 1 plus x squared 2 over 6 plus x squared 6 over, oh shoot, this is 2, never mind. 2 is equal to, oh my god. 2 is supposed to equal to the square root of 3. So when you solve for this equation, you basically get, this is pretty messy here, but we don't need this. You get that x is equal to 2 root 2 minus 6. Now we know the whole area since we have a value for x and this whole length there. Okay, we know that the area, the big area, is 8, since there's 8 triangles, times 1/2 for the triangle formula, times x root 2 over 2 times x root 6 over 2. I'm writing it in simpler terms like this. And then you have to add the 4 times 1 times x root 6 over 2, which is really this height. And then you have to also add this area, the other area, so x root 2 plus 1 squared. When you basically add these all up and substitute for the value of x, you get that the whole area is equal to 16 root 3 minus 23. And now, you might get stuck because you can't compute this. But the problem asks for the area in this form, so we want m plus n plus p. In this case, we just sum the numbers up. So 16 plus 3 minus 23 is equal to our answer of -4.